Hey everybody! Today we are going to solve some equations and we are going to be doing some things within this lesson that you've been currently working on. Before I explain this problem that's worked out to you, I want to go back and talk about something from a long time ago. So I'm just going to give you the equation x squared equals 9. And I'm just going to write that out twice. Okay, so from a long time ago, we learned that to get rid of a squared, you square root. And I taught you that when you square root to slap down a plus minus. And I'll explain why again in just a second. So on the left side, the squared and square root cancel. So all you have left is x. And then the square root of 9 is 3, because 3 times 3 is 9. So I want to explain why both of these answers make sense again. If I went back to the original problem and I put the positive 3 in, so I'm putting my positive 3 in, and I want to know, does 3 squared equal 9? 3 squared, 3 times 3. Yeah, that's a 9. So my positive 3 is an answer. Let's see if negative 3 is an answer. So if I take negative 3 times negative 3, is that also a positive 9? Yes. So when I take a square root, I get a positive and a negative answer that work. Okay, well, let's look at an equation that we haven't really talked about before. If I had x cubed equals 27, if I wanted to get rid of a cubed, I would cube root. To get rid of a squared, I square root. But to get rid of a cubed, I would cubed root. So I'm going to cube root both sides. The cubed and cubed root cancel each other out, so all you're left with is x. And then on this one, let's see if the plus minus works. So the cubed root of 27, what times what times what? 3 times makes 27. 3. Well, let's see. If I put in my positive 3 that I just got for an answer back into the original equation, let's see if that works. 3 times 3 times 3. Is that 27? Yes. Well, what if I said it was a plus minus? Let's see if negative 3 cubed makes 27. Does negative 3 times negative 3 times negative 3 make a positive 27? Negative 3 times negative 3 times negative 3. What do you think? No. Negative 3 times negative 3 is a positive 9 times another negative 3 is a negative 27. So no. So this one, there's only one answer. Okay, so what I want you to know is that if you ever take an even root, you're going to have a plus minus. So when I say even root, I mean if I take a square root, a fourth root, a sixth root. If I take an odd root, like up here, the number 3 is an odd number. So if I take a cubed root, a fifth root, a seventh root, I won't have a plus minus. And that's because it didn't work. When I tried to put negative 3 back into the original problem, it did not give me a positive 27. Whereas when I put the positive 3 in this one and the negative 3 in this one, they both worked. Okay, so here's my little chant for this saying. When you take an even root, there's a plus minus. When you take an even root, there's a plus minus. Okay, so anytime you take an even root, we need to slap down our plus minus. If we take an odd root, it's only going to be one answer. It'll either be a positive answer or it could be a negative answer. So like if I asked you to take x cubed equals negative 27 and solve that, to get rid of the cubed, I would cube root. And then the cubed and cubed root would cancel. And so do you think a positive 3 times a positive 3 times a positive 3 would make a negative 27? Nope. But a negative 3 times a negative 3 times a negative 3 would make a negative 27. So when you take an odd root, you're either going to get a negative answer or you're going to get a positive answer, but you will not get both. Only when you take an even root. So when you take an even root, there's a plus minus. When you take an even root, there's a plus minus. Okay, you're going to hear me say that many more times. All right, I don't know if I want to explain going through this problem for you or just start with the problem blank. And then if you wanted to go back up and look at this, then you could go back up and look at it. I think I'll just do that. So I'm just going to start a problem fresh. All right. So our number one goal to begin with, wherever the x is, it's going to be in parentheses today, raised to a fraction exponent. We need to get that by itself before we do anything else. So in every problem, I'm going to look for where the x is, and I'm going to look for its fraction exponent, and I'm going to get it by itself before I do anything else. Okay, and these may not look like exponents, but that's just because the program I have to use when I type these equations in doesn't seem to make it go up high enough, so I apologize. All right, so if I want to get this by itself, first I would have to move away the minus 2. So to get rid of subtraction of 2, I have to do the opposite, which would be to add. So this zeroes out. 25 plus 2 makes 27. And then the left side's just going to come down. So I've got x plus 1 raised to the 3/2. Okay. Once your parentheses with the fraction exponent is by itself, then we're ready to get rid of this fraction exponent. So we're going to raise it to the reciprocal exponent. So I want to flip this fraction over. And if I flip it over, it would be 2/3. So I'm raising this side to the 2/3 power, which means I have to raise this side to the 2/3 power. Okay, so this now gives me 6 over 6. Well, what's 6 over 6? 1. And exponents that are 1 aren't even necessary. So this just goes away. Shoop, shoop. So all I'm left with on the left-hand side is an x plus 1. And on the right-hand side, I'm left with 27 to the 2/3. So I need to calculate this. So this is what we were doing for the last several days. I need to figure out around the world what the cubed root of 27 raised to the second power is. So cubed root of 27 raised to the second power. Now, I'm solving an equation here. Am I taking an even root? Nope, I'm taking an odd root, a cubed root. So remember, when you take a cubed root, an odd root, you only either get a positive answer or a negative answer. You don't get the plus minus. So I don't have to worry about a plus minus unless I take an even root. Okay, so what's the cubed root of 27? 3, because 3 times 3 times 3 is 27. And then I'm going to raise that to the second power. And then what is 3 squared? 9. Okay, so this side became a 9. So now to get x by itself, what would I do? I would subtract 1. And then the x would come down, and what's 9 minus 1? 8. And that's my answer. Okay, so we're doing some solving equation skills here, which you've known about solving equation skills for years. And then we're doing our around the world thing that we've been working on for several days now. So the denominator is the root you take, and the numerator is the power you raise it to. And if I take an odd root, I don't have to worry about a plus minus. But if I take an even root, I will worry about a plus minus. Because when you take an even root, there's a plus minus. Okay, so basically, if this denominator is even, then we will have a plus minus in the next step. Okay, if the denominator is not even, you will not have a plus minus in the next step. All right, let's look at number 2. All right, so I need to get the stuff in parentheses with the fraction exponent by itself. So to get rid of this 3, since it's smushed against the parentheses, it's multiplied. So to get rid of multiplication, I divide. So I'm dividing both sides by 3. The 3 divided by 3 is 1, so that goes away. So that leaves x plus 1 raised to the 3/5. And on the right-hand side, 24 divided by 3 makes 8. Okay, so once the variable is in parentheses with the fraction exponent, it's all by itself. I'm going to get rid of that fraction exponent by taking it to the reciprocal exponent. So I flip that fraction over, so 5 over 3, and so then raise this side to the 5 over 3. So this is 15 over 15, which is 1. So that just goes away. Shoop, shoop. So all I'm left with is x plus 1 on the left-hand side. The parentheses just go away at this point. And on the right-hand side, I need to go around the world. So this is asking me to take the cubed root of 8, so cubed root of 8, and raise it to the 5th power. Will I need a plus minus? Nope, because I'm not taking an even root. I'm taking an odd root. All right, what's the cubed root of 8? What times what times what is 8? 2. And then I need to take 2 to the 5th power. 2 times 2 times 2 times 2 times another 2. Anybody know what that is? It's 32. All right. And then to get x by itself, I get rid of addition of 1 by subtracting 1. And what do I get if I subtract 1? 31. 32 minus 1 is 31. Okay, let's go to number 3. If you will notice, the stuff in parentheses with the fraction exponent is by itself this time. In number 1, there was something subtracted behind it. In number 2, there was something multiplied up against it. In this problem, it's by itself. So I'm ready right now for the reciprocal exponent. And the reciprocal to this is 3 over 2. And I have to raise both sides to that power. So this side, shoop, shoop, that goes away. All you're left with is x plus 5. And this side, I need to go around the world. So this is telling me to take the square root of 4 and raise it to the 3rd power. Am I taking an even root this time? Yes, I am. If this denominator is even, we're taking an even root. This is a square root of 4, and when you take an even root, there's a plus minus. So the square root of 4 is 2, but plus minus, and then I'm going to raise it to the 3rd. So 2 times 2 times 2 is a positive 8, and negative 2 times negative 2 times negative 2 is a negative 8. So this makes a plus minus 8. And then to get x by itself, how do I get rid of addition of 5? I subtract 5. Okay, so now I'm going to have 2 answers here. So this is telling me first to take my positive 8 and subtract 5. So what's 8 minus 5? 3. Then it's telling me to take my negative 8 and subtract 5. And what's negative 8 minus 5? Negative 13. And those are my 2 final answers. Okay, what'd you think? Just remember, if this denominator is even, you're taking an even root. And when you take an even root, there's a plus minus. All right, let's look at number 4. So number 4, I need to get the stuff that's in the parentheses with the fraction exponent by itself. So I'm going to have to get rid of the 4, and I'm going to have to get rid of the plus 6. So typically when we solve equations, we get rid of addition, subtraction first. So I'm going to get rid of addition of 6 first by subtracting 6. So that zeroes out. The 4 and then the x minus 3 to the 3/4 comes down. And on this side, 70 minus 6 makes 64. Okay, I'm still trying to get the variable that is in parentheses with the fraction exponent by itself. So how do you think I'll get rid of that 4? I'm going to divide by it. Since the 4 is smushed with the parentheses, I need to divide, because smush is multiplication, and to get rid of multiplication, we divide. So 4 divided by 4 is 1, so those are gone. I'm left with x minus 3 raised to the 3/4. And on this side, do you know what 64 divided by 4 is? It's 16. Okay, so once I have my variable in parentheses with the fraction exponent by itself, I'm ready for the reciprocal exponent. So what do you get if you flip that fraction over? 4/3. So I'm going to raise both sides to the 4/3 power. So the 3 and 4s cancel. Shoop, shoop. all I'm left with is x minus 3 on the left-hand side. And on the right side, I need to go around the world and figure out what 16 to the 4/3 is. So this is telling me to take the cubed root of 16. Oh no, that doesn't work out. Okay, that's a bummer. You can't take the cubed root of 16. I think I wanted this to be something different than what it was. I just made this problem up on the side and it's not working out. So the cubed root of 16 does not work. So I'm just going to put no solution here. This should not happen to you as you're working your problems. So there's nothing that you could multiply 3 times together and get 16 for an answer. So that's why I can't do this. So I'm just going to write no solution on this, but you would just do it like we've been doing. If it did work out, there would not be a plus minus because it's not an even root. And then at the end, I would add 3 to both sides. But this one doesn't work because you can't take the cubed root of 16. So I'm sorry about that. All right, so I want you to try 2 problems for me. I want you to try number 5 and number 6. Let's see how they go. And then once you've done these 2 problems, then I want you to post a picture of your work and put it on Canvas. And that's all for today. Smiley face.